friends, welcome back to our channel STM Mechatronics. So in this video we will see one bug that we have encountered in the last code. So the bug was like whenever we are going to write the data at the sector boundary, right? So the data was getting written in the same page. So that was the bug. I'll explain you more. So let's suppose this is the address, and these are the byte data, right? Byte. So let's suppose this is 0th byte, 1 2 3 4 5 5 6 7 8 9 10, likewise go on counting to 16, right? We'll take 16 only. So here we'll put the address 0x000000, 24 bits of address, right? 3 byte of address we have. So we are going if you go on writing the data from this to like 0 0 0 1 0 0 0 0 0 2. Let's suppose we go on writing data till first sector boundary, right? That is 256. F0 data will be 0x 00 00 10 0x 00 00 20. Okay, so let's suppose we have some data over here in these cells, right? In this page we start writing data from here, right? So let's suppose I want to write STM Mechatronics, right? STM Mechatronics. So the next data should be like here at the address 000100. The next data should come at this address, right? But the data was getting written over here. So and it was like if we have larger data, it was getting written in the same page. So this is the same page, right? Because we have 256 bytes per page. So from 00 to FF we can write, right? So data was written, if we start writing data from here, right, the data was getting written in the same page from the first location. So data was getting written here. The correct way is like it should get written over here, right? And from here it should get the bytes should be written in the consecutive addresses. So this was the error that we have found. Now why this was error, why this error was there, or why this bug was there? Because in our code we have not implemented that logic, so we have not handled that memory address logic. So the earlier code, if we see the earlier code, it was something like we were only checking the number of bytes. If it is greater than 256 bytes, then we were writing the data bytes equals to 256, and then we were reducing the data length by 256 bytes. And if the remaining data length to write in the memory address is less than the 256 bytes, we were directly assigning it to the data bytes to return, and we were making the data length as 0, right? So now we have added this part of the code, right? We have slightly modified and we have added some part of the code. So this logic we have added basically. So I will explain you why this logic was why this logic was added, that I have explained it to you. Now how it works, that I'll explain it to you. So we have seen if the data length, right, means the bytes to write in the memory is greater than 256 bytes, because bytes per page is 256. So the data length is greater than the bytes per page, then we will assign it that bytes to write is equals to bytes per page. Okay, now we will come over here. Now we will check if memory address, right, if data length is less than bytes per page, means the remaining bytes to write is less than 256, then it will come in the else loop. Now here it will check that if the memory address, it will check here that if the memory address modulus bytes per page, that is memory address divided by 256 bytes, whatever the remainder is not equals to 0, means the memory address is exceeding the bytes per page, right, or the memory address is at the sector boundary. So it will come like here, the remaining bytes to write will be equals to bytes per page 256 minus memory address modulus bytes per page. I will explain you. If the memory address is ff, that is 255, right, if we are writing the data at 255 address, so the modulus of 255, right, modulus of 255 bytes per page, this is bytes per page, 256 is the bytes per page, it will be equals to 255, right, because 255 divided by 256 will be 0 and the 255 will be remaining, right. So address is coming at this end location, right. So from end location we should start writing the data and we should go to the next page, correct. So what we have done is, we are bytes to write will be calculated as 256 minus 255, the modulus, this 255 came as 255 modulus 256, right. So this came as 255 modulus 256. So we get 1. So we have to write 1 byte in that page, okay, with this memory address. Now once that is done, we will get the bytes to write, that is 1 byte of data we have to write with 2ff address, okay. Now it will come, the logic is same, we will convert the 24-bit memory address into array of uint 8. We will then provide the memory address, 3 byte of address, okay, then we will send the data. Now with the address 255 we will send only 1 byte, okay, then we will chip select, we will terminate the data transfer. Now we will increment the memory address by 1 byte, that is this way, from here we got, right, from this formula we got the bytes to write. So with that we will increment the memory address, with that we will increment the pointer, okay. Now we have reduced the data length by bytes to write. So in this case we wrote only 1 byte, correct. So data length minus 1. But now currently we will see that if the data length is again not equals to 0, it will come over here again and it will check if the data length is greater than bytes per page, okay. Now again here we have not considered the same logic, we will have to reconsider the same logic over here also. So if we will add like this, if mem address modulus bytes per page, okay, is not equals to 0, is not equals to 0, then we will go over here, okay. Else, like if it is the starting byte, then we will write, we will directly write the 256 bytes, okay. Control X, Control V, enter, right. I will come over here, we'll apply again this same formula, bytes to write, okay. The formula is same, okay, the formula is same, but only instead of bytes to write in the second condition, so whenever like the memory address is the start of new page, then we will write 256 bytes if the remaining bytes is greater than 256. So we'll directly write the 256 bytes. Okay, so this way our code will work. Now we will test our code with both, like the data is less than 256 bytes and the data greater than 256 bytes. Okay, data length, basically the data length. Okay, so we'll go to main, we'll come over here. Now we can see that we have STM Metatronics in embedded system, this string. This is obviously less than 256 bytes. So we'll come. Okay, we have build our code. Again the simulation, again the simulation is same as that of the last video. So the simulation file is same as that of the last video. We have not modified anything. So we will go into configuring power rails, ground. So in the ground net we have ground and VSS. In the VCC we have 3.3 volt power supply, VCC and VDD, and in the VE section we have 0 volts of power supply. Okay, in this chip 8225F4096 we have total 524288 bytes. Okay, this becomes 512 kilobytes, and the page size, as you can see, is 256 bytes. The sector size is 65536, that is 64 KB. Okay, the memory write cycle is 30 seconds. So all these have been taken care. Now we will run the simulation. Okay, we'll check. First we have given the erase. Now first, like after initialization, we have given the chip erase command. Okay, there are total 8 sectors. So erasing one sectors takes around 1 second of time, and total 8 sectors means 8 seconds of time. So that's why there is a 8 second of delay for total chip erase. Okay, yes. So if you see, like we have started writing data from FF, right? In the write memory data, right, we have given the address as FF, right? Sector is FF and write memory data FF. Okay, so we have started writing data from end, like page end address, that is FF. So the data should get written in the next page, right? So as we can see that, like this is FF address, right? Address FF. We have our data is successfully written over here, and the remaining data is written on the next page. Okay, next page, and it is written correctly. So STM Metatronics in embedded simulation, right? That is written correctly. Now we will go in our code and we'll put some string, a large string. So we'll put some large string as this, ABB CCDT. Okay, again chip erase will take around 8 seconds of time. Now as you can see, in the first sector and in the second page, sorry, in the first page and in the second page, whatever data we have written, it is erased. It is erased successfully. Now we will have to wait for 8 seconds because the total chip erase time is of 8 seconds. So the total chip erase time is of 8 seconds. Now our data is written, as you can see, like AABB, right? Now from here, right, 1FF, the next page will start. So whatever data, it should get written over here. So we'll check that. Okay, from 20, we can see that from 20 data is written properly. Now we'll check. So we have total first page, second page, and the third page. So there are like 3 pages of data, right? You can see AA 2 3, right? BBB, V, XX, DD, SS, DD, VV, and some random data. So here we can see A, large number of A, then BB, VV, XX, DD, SS, DD, then again random data, right? Now we have given the sector erase command. Sector is of 65536 KB. Sorry, sector is of 65536 bytes, that is 64 KB, right? So again over here we can see that at the end of the sector, at the end of the page, the data is written correctly, that is S, starting off our string, first string. Then we will check STM Metatronics in embedded simulation, and then the rest of the data. Okay, so yeah, we have resolved that bug. We can write successful data with the page end address, and we can write data anywhere in the memory location, allocated memory location. Now we will have to use the same logic in the read function also. So instead of bytes per page, write this as Control C, Control V, and write bytes per page. Okay, we'll save it. Okay, let's try to optimize this code. Control C, Control V. Now what I was thinking is I can get it like this. Instead of this, we'll put it over here, right? So if the memory address modulus bytes per page is not equals to 0, we will write data bytes is equals to this. Else we will come over here, and then we will check that bytes to write, right? So if data length is greater than bytes per page, so data length is greater than bytes per page, data length is greater than bytes per page, then we'll give this, right? Else directly give it as data length, right? Right. So yes, we have optimized few lines of code. I will check if that works. Chip erase. Yes, so yes, we have optimized our code. So it works, right? Now we will use the same thing in our read function also. So basically we will copy this whole code. Instead of data bytes to write, we will use the data bytes to read. Okay. Bytes to read. Yes, so we'll copy over here, paste, paste, paste. Yep. So yep. So I hope you find this video informative. So this is one way how do we find our bugs by continuous improvement or continuous optimization. So if you like the explanation, if you like my video, give it a like, share with your friends, and thanks for watching. Have a nice day.